Hi, I'm John Galenzi, Director of Software Technology Evangelism at Apple. In this video, I'll provide you with an introduction to the tools and technologies you'll find in the iPhone SDK. Understanding what's included will help you better plan exactly what you want to build. The iPhone SDK includes everything you need to build the next generation of innovative mobile applications for the iPhone. And with access to the rich set of APIs, you can create applications with amazing user interfaces that leverage groundbreaking multi-touch and animation technology available only on iPhone. The iPhone SDK also provides a complete set of development tools, including Xcode, Instruments, the iPhone Simulator, and Dashcode. These are the same powerful tools we use to develop macOS 10, macOS 10 Server, and all of the software on iPhone. These same tools are now available for you to develop your iPhone application with. There's a lot to talk about, so let's get started. Let's begin by talking about the development tools that are available. First, there's Xcode. Xcode is the integrated development environment for building iPhone applications, providing project management, a powerful source editor, a graphical debugger, and a set of templates and sample code to get you up and running quickly. Secondly, there's Instruments. Instruments is an application for dynamically tracing and profiling your application's code in real time. Instruments is a flexible and powerful tool that lets you sample various aspects of your application, such as memory usage, performance characteristics, and the like, and display the results graphically on a sampling timeline. This tool allows you to see exactly where you should be tuning your code to increase efficiency and performance. Next, there's Dashcode. Dashcode's integrated environment allows you to lay out your user interface, write code, and even test web content without the need for any other applications or tools. Its layout tools, composers, and editors simplify the process of creating all the resources an iPhone web application needs. It also includes handy coding and debugging tools that help you manage and test any code you write for Safari and iPhone before deploying it to the web. And finally, there's the iPhone Simulator. During development, the iPhone Simulator makes it possible to run and debug applications without connecting an iPhone. The iPhone Simulator implements the iPhone API, providing an environment that resembles the environment provided by the iPhone itself. The iPhone Simulator provides native and web application developers with a realistic preview of how their content will look on iPhone, only it's running locally on your development machine. So that's a quick summary of the development tools included with the iPhone SDK. But before we move on, I'd like to show you how quickly and easily Xcode and the iPhone Simulator can get you up and running with a sample project. All right, so let's simply open up Xcode on your Intel-based Mac. Then we're going to select New Project from the File menu, and this will bring up Xcode's template chooser. We'll use the Cocoa Touch list template. OK, let's give it a name, Sample, and save it to the Documents folder. Now, Xcode is going to handle any dependency checking, compilation, and linking, and automatically package up our code into an application bundle. Once it's done, Xcode will launch the simulator and then our application. Now, interact with your application by flicking, dragging, clicking, and even pinching. You get the iPhone experience directly on your desktop. And when you're done, simply click the Xcode Stop button. It's that straightforward. Isn't that great? The templates provided by Xcode and the sample code project we've assembled provide a great base for you to build upon. And it's easy to get started, as you've just seen. And the development experience only gets better as you start to use the entire toolset and dig deeper into the frameworks. So let's do that and take a closer look at the extensive frameworks and technologies included in the iPhone SDK. Now, first of all, it's important to understand that the iPhone SDK has a layered architecture. The lower layers provide the fundamental services on which all applications rely, and the higher layers contain more sophisticated graphics and user interface related services and technologies. Let me introduce them all before I go in depth on each. The lowest layer is the Core OS layer. This layer encompasses the kernel environment, drivers, and basic interfaces of the operating system on iPhone. It manages virtual memory, threads, the file system, networking, and inter-process communication. The layer above that is the core services layer. This layer provides the fundamental system services that all applications use. Even if you don't use the technologies at this layer directly, every other technology in the system does. Next is the media layer. The media layer contains audio, video, and graphics technologies, all of which are geared towards creating the best multimedia experience available on a mobile device. More importantly, these technologies were designed to make it easy for you to build media-rich applications super fast. This layer is comprised of high-level frameworks that enable advanced graphics and animations, and low-level frameworks that provide you fine-grained control when required. Finally, we have the Cocoa Touch layer. This layer provides the primary classes for implementing a graphical, event-driven application. Every application in iPhone uses this framework to implement its user interface elements and behaviors, such as windows, standard views and controls, event handling, text management, and much more. It also includes several other frameworks that provide key services for accessing device features, such as the contacts and photos, the accelerometer, the built-in camera, and much more. Let me talk about the CoreOS layer in detail. The CoreOS layer provides the fundamental system services that all iPhone applications use. At this level, the iPhone SDK provides a set of interfaces for getting at many low-level features of the operating system on iPhone, which your application accesses through the lib system library. The lib system library provides wrappers for many low-level features of the system. It's C-based and supports many features, including threading via POSIX threads, networking, file system access, standard I/O, Bonjour and DNS services, locale information, memory allocation, and math computations. Next, one layer up, is the core services layer, which provides the fundamental system services that all iPhone applications will use. The core services layer is comprised of numerous frameworks and libraries that all iPhone applications will use, even if indirectly. The first framework within the core services layer is Core Foundation. If you're familiar with development on macOS 10, you'll already have lots of experience with this valuable framework. Core Foundation is a set of C-based interfaces that provide basic data management and services, including collection data types like arrays, sets, and so on, bundle support, string management, date and time management, and a whole lot more. In addition to Core Foundation, there's the CF Network framework. The CF Network framework is a high-performance, C-based framework that provides a set of object-oriented abstractions for working with network protocols. These abstractions give you detailed control over the protocol stack and make it easy to use lower-level constructs such as BSD sockets. You can use this framework to simplify tasks such as BSD socket programming, communicating with FTP and HTTP servers, Bonjour networking, resolving DNS hosts, or setting up encrypted communication channels, among other things. In addition to its built-in security features, iPhone SDK also provides a security framework you can use to guarantee the security of the data your application manages. This framework provides interfaces for managing certificates, public and private keys, and trusted policies. It supports the generation of cryptographically secure pseudo-random numbers and supports the storage of certificates and cryptographic keys in the keychain, a secure repository for sensitive user data. For database support, the core services layer includes the SQLite library. iPhone ships with the open source SQLite library built right in. This library lets you embed lightweight SQL database support right into your application, allowing you to create local database files and manage the tables and records using standard SQL syntax. The SQLite library is designed for general-purpose use, but is still optimized to provide fast access to database records. Therefore, you may want to seriously consider using a database instead of files for storing your application data. The final set of libraries in the core services layer provides support for XML. iPhone's built-in support for manipulating XML content is provided by the libxml2 and libxslt libraries. These are open source libraries that you can use to parse or write arbitrary XML data quickly, or, for example, transform XML content to HTML. So that completes the core services layer. Next, we come to the media layer, containing everything relating to audio, video, and graphics. The graphics and media technologies in the iPhone SDK are designed to deliver the best experience for games and other media-rich applications. The high-level frameworks make it easy to create advanced graphics and animations quickly, while the low-level frameworks provide you with much more fine-grained control if you need it. The iPhone SDK allows you to add high-quality graphics to your applications via several 2D and 3D drawing technologies. First, there's Quartz. Quartz is a C-based 2D drawing engine for vector graphics, lines and shapes, patterns, gradients, images, and more. Next is Core Animation. Core Animation is an Objective-C API that lets you create smooth animation and dynamic feedback in the user interface of your iPhone application. I'm sure you have already seen lots of examples of animation on your iPhone. For example, screens slide back and forth to change, flip around to reveal simple preferences, curl up to reveal features in maps, and morph into the trash can when deleting mail or notes. It's extremely simple to do these types of animations because many of the standard animation behaviors are already integrated into the view classes in UIKit. By simply changing properties of a view, you can trigger an animation, or you can create custom animations with only a few lines of code. The third graphics framework is OpenGL-ES. OpenGL-ES is the mobile version of the OpenGL standard and is the interface for high-performance 3D graphics on iPhone. OpenGL-ES gives you ultimate control to take advantage of the full speed of the graphics hardware and is well suited for games and other applications that must draw at high frame rates. The iPhone SDK supports audio in your application through the Core Audio and Audio Toolbox frameworks. The Audio Toolbox can be used to play short sounds and to trigger a vibration on devices that support it. Core Audio provides an advanced interface for playing and recording audio and for capturing audio streams. In addition to these frameworks, the iPhone SDK includes support for OpenAL. OpenAL is a cross-platform standard for 3D spatial audio, particularly targeted for game developers. And finally, there's video. The media layer of the iPhone SDK provides support for full-screen video playback through the Media Player framework. This framework supports a number of compression standards for both audio and video, including H.264 baseline profile level 3 video, up to 640 by 480 at 30 frames per second. Also supports simple profile MPEG-4 Part 2 video, and AAC-LC audio up to 48 kHz. All right, so that completes the media layer. Now let's pop up to the top layer of the technology stack and talk about the Cocoa Touch layer. This layer provides the primary classes for implementing a graphical, event-driven application on iPhone. Every application on iPhone uses this framework to implement its core user interface, such as windows, standard views and controls, event handling, text management, and much more. Cocoa Touch also includes several other frameworks that provide key services for accessing device features, such as contacts and photos, the accelerometer, the built-in camera, and so on. The first and perhaps most important framework in this layer is the UIKit framework itself. UIKit is an Objective-C-based framework that provides the primary classes for implementing a graphical event-driven application. You'll use aspects of UIKit for application integration. Application integration means your application can leverage features of other applications on iPhone by simply sending a system message that they've registered to handle. By calling a single application method and passing in the appropriate string, you can have the iPhone dial a phone number, or open Safari to a certain page, or open iTunes to an album, run a search, or whatever. Drop a pin in the Maps application, display a YouTube video, or create and pre-fill a message in Mail. Or you can even open other applications that have registered support for a custom protocol, even other applications that you've authored. UIKit also provides graphics and windowing support, and provides everything you need for event handling. Let me explain. Events are based on a multi-touch model. Instead of using a mouse and a keyboard, users touch the iPhone or iPod Touch screen to manipulate objects, enter data, and otherwise convey their intentions. The operating system on iPhone recognizes one or more fingers touching the screen as part of a multi-touch sequence and tracks fingers touching the screen, recording the characteristics of each of them, including their location and, in certain cases, their direction of movement. Using UIKit's event handling capabilities, your iPhone application can recognize certain combinations of touches as gestures and respond to them in ways that are intuitive to users. For example, zooming in on content in response to a pinching gesture and scrolling through content in response to a flick gesture. UIKit also provides reusable objects representing the standard views and controls that you'll need. Views are the basic building blocks for creating the user interface of your application on iPhone. Views are the objects you use to lay out your data and controls. Nearly every object that appears on the screen is a view, including windows. Standard controls have a consistent appearance and behavior across all iPhone applications and allow users to work in an environment that's predictable and familiar. Now, to be clear, not all of the controls you see displayed here are necessarily available at this time within UIKit. My point here is simply that it's these types of elements that are used everywhere in the applications on iPhone, and you should do everything you can to use the built-in controls available to you so your application fits in too. UIKit provides support for embedding web content and text services, and it provides access to accelerometer data which you use to determine the motion of iPhone in the 3D space. Now this is very cool. An accelerometer measures changes in velocity over time along a given linear path. The iPhone and iPod Touch each contain 3 accelerometers, one along each of the primary axes of the device. This combination of accelerometers lets you detect movements in any direction and then use this data to track both sudden movements in the device and the device's current orientation relative to gravity. UIKit provides access to the device's camera too. There's a class that displays a standard system interface for taking pictures using the available camera, and it also supports optional controls for resizing and cropping images, as well as selecting photos from the user's photo library. Finally, UIKit provides support for reading device-specific information like screen orientation, serial number, OS version, and more. OK, in addition to UIKit, there are a couple of additional building block frameworks in Cocoa Touch Layer as well. While these building block technologies are not required to build an application, they do provide valuable services and features that allow you to integrate with the system and provide a much better user experience for users. For example, the address book framework provides access to the system's contacts database. Using this framework means contacts used by your application are the same ones users see in other applications. You can use the address book UI framework to display the standard user interface for picking contacts from the user's contact database. This means picking contacts within your application will be the same consistent experience it is in other applications. Lastly, the core location framework lets you add features to your application based on the current latitude and longitude of the iPhone. This is the same technology used by Maps to show the user's current position and uses the built-in hardware to triangulate the user's position based on nearby Wi-Fi networks and cell towers. OK, so that concludes our look at the extensive technologies available in the iPhone SDK and the overview of tools and technologies available for you to use. The definitive place to look for iPhone developer resources is developer.apple.com/iPhone, where you'll find orientation videos, technical documentation, and lots of sample code. And relative to the orientation videos, I encourage you to watch each one of them because they go deep on each of the topics that I've covered here today. Finally, feel free to contact me at galenzi@apple.com with any questions you may have about the material in this video. So, as you've seen, the iPhone SDK includes an incredible set of development tools for coding, debugging, code analysis, performance tuning, and simulation. And it's packed with dozens and dozens of rich frameworks and technology stacks capable of handling almost any task you have. The iPhone SDK opens a new frontier for mobile application development and provides you with extraordinary opportunities. I look forward to what you're going to do with all this technology and hope to see your innovative and focused solutions on iPhone soon.